All right, so our do now for today is to look at this and remember that you do this first. So the first thing we're going to do is follow the rule. There we go. T3, 4. So what's going to happen to my coordinates? I'm going to add 3 and add 4 to the x and the y. So m prime is now going to be at 1, 9. And a prime is now at 9, 4. Okay, and the second thing we're going to do is a reflection across the x-axis, and again, x, that means x stays, y changes. So for the second part, which is a reflect across the x-axis, my new coordinates are m double prime, because this is the second thing I'm doing. The 1 stays the same, the y goes negative. And then a double prime, the 9 stays the same, and the 4 goes negative. Please remember to be working on your IXLs. In math, you have to practice to be successful. All right, so we're going to watch this quick brain pop video that I'm going to pull up, and then because you don't have access to it, and then we'll continue on with the lesson. I guess the brain pop video is not working, so real world examples of transformations would be like wallpaper, t-shirt designs, paintings, anything that has to do with like sliding, whatever. What 3 transformations have we learned so far? Well, we've learned rotation, reflection, and translation. And if you think of the word dilation, if any of you have eyeglasses, they dilate your eyes. So that's one example. And when we look here, we've got 3 pictures of Beyonce that have been dilated. So you can see that it's the exact same image, it's just different sizes. And so that's what the word dilation means, is that like perhaps this right here is 2 times bigger, so we'd say it has a scale factor of 2. And let's say from here to here, this image is 3 times bigger, so we'd say that it has a scale factor of 3. Okay, so that's what a dilation is. It's the same shape, the same image, it's just bigger or smaller. All right, you can read this. It's a dilation in which a dilation is a transformation in which the size of the figure is changed. Remember, all the transformations we talked about up until this point, we call them rigid, and it's rigid because it doesn't change, right? So now we're going to talk about a dilation, and that is a change in size, but not a change in the figure, okay? And so we're going to be multiplying the coordinates. So the way we talk about a dilation is we use the letter D, capital letter D, or you can write the rule in arrow notation, which would mean that you're just simply going to multiply your x and your y coordinate by the same number, and we call this number your scale factor. So if this was my original point, my new point would be at negative 16, comma 8, because negative 4 times 4 is negative 16, and 2 times 4 is 8. Okay, so these are the 2 different ways you'll see a dilation here. And we call this number right here, we call that your scale factor. That's the number you're scaling by, or you're making it larger or smaller by. Okay? So let's look at an example of a dilation by a scale factor of 2. So we write this with a uppercase D and a little 2 by it. Anyway, so I'm going to draw a line segment that is 3 units vertically. It can be anywhere. I'm going to do 1, 2, 3. This is my vertical line segment. Now I'm going to double the length. So my new line segment is here. So that's my new line segment. So my original line segment was 3. My new line segment, I'm going to write an arrow because I did a dilation of 2, makes it 6. So all I did was do 3 times 2, which is 6. You can try it again if you like, but that's what's going to happen. So now we're going to write a rule. So if k is greater than 1, then the dilation is an enlargement. Okay, so if you go from here to here, that's an enlargement of k greater than 1. So k is another word, is the variable we use to represent scale factor. Now here, if it's a reduction, then we're going from the large image back to the small image. And so that's when you have a fraction or a decimal k-value. So it's between 0 and 1. You have a reduction. Okay, so that's kind of tricky. All right, let's move on. So once again, we're going to do a composite function, but we're going to start with a dilation, right? So we're going to dilate the coordinates by 1/2, which means it should be a reduction. So we're going to multiply all of our coordinates times 1/2. So dilation of 1/2, my new k value will be at 1, -2. Y will be at -2, -2. L, -2, 3. And E will be at 1, 3. Notice I've just multiplied each of the coordinates by 1/2. Okay, and then the second thing I'm going to do is reflect across the x-axis. And again, I'm going to write my rule. X stays the same, y changes. Okay, so my new coordinates here are 1, 2, -2, 2. L is at -2, -3, and E is at 1, -3. Now I'm going to graph it and make sure that I did this correctly. So I'm going to start with my original image in black. So I'm going to go 2, -4, -4, -4, -4, 6, and then 2, 6. Okay, so I started out with a rectangle. Then I dilated it by 1/2, so it's going to get smaller. 1, -2 is here. -2, -2 is here. -2, 3 here. And then 1, 3 is here. So that's my dilated image. And then finally, I reflected it across the x-axis. So this right here is the x-axis. And so this now is down here. Here, here. So it just kind of rotated it around itself. Go ahead and try this one on your own. Again, this time, notice that your dilation is 2. So you should be thinking, okay, I'm going to start with a smaller image, and it's going to get larger. And then remember, when you rotate 90 degrees, let's go ahead and do a counterclockwise 90 degree. So that means the one on the left is going to change, so -y, x. These are the coordinates you should have ended up with, and you should have noticed that your original figure is twice the size of the original hop, and then it probably turned one quadrant to the left. All right, now it's time for you to practice this on your own. Go ahead and finish the packet. And then when you are done, you can come back to the video and check your answers, or you can wait until tomorrow when we check our answers together as a class. But please, this is not the time when you just look at the answers and copy them down in your paper so it looks like you're finished. Remember, math is all about practice. So you want to make sure you're practicing them first, then checking to see if you made any errors. Otherwise, if you do it any other way, you're not learning anything. Hopefully, you're coming back to this video because you've finished the packet, and then you can work on your IXLs 2, 4, 5, and 8 when you're done checking your work. So first, notice that it says use the rule 4x, 4y, so you just take your coordinates and multiply by 4. Here, you're just multiplying by 5. And here you're multiplying by a scale factor of 2 to get a double prime. But notice it was looking for a. So you actually have to then divide by 2 to go back to where you were previously. So if you were at point A, 3, -1, and then you applied a scale factor of 2, then you would end up back here at 6, -2. So be careful on the wording on this. Okay, go ahead and check. Notice I did the first step on the left, and then I did the second step on the right. So again, this little dot here means it's a composition function, and you're going to do what's on the right first and then what's on the left second. So this is a result of what happened here. Okay, again, remember your test is going to be next week, probably Tuesday or Wednesday. So be ready. We're moving pretty quickly through this because we want to have time at the end to do those extra units. All right, if you have questions, let me know.